Hello everyone. So in last lecture we have seen design procedure of knuckle of a turnbuckle. Okay. So step 1, step 2 and step 3. We were seeing step 3. So as I told in last lecture that once you know core diameter from step 1, then you can calculate nominal diameter, that is DO, okay, from empirical relations. So these all are empirical formula for turnbuckle. Okay, once you know the core diameter, you can either calculate nominal diameter from this empirical relation or from a table given in question. Okay, so remember these empirical relations or empirical formula for turnbuckle. Okay, so DO can be calculated from these. Once DO is calculated, that is nominal diameter is calculated, then you can calculate the small l value, that is small l value for steel is in between DO to 1.25 times DO, and for cast iron it is between 1.5 times nominal diameter to 2 times of nominal diameter. Then small n value is number of threads per of length, which is equal to 1 upon pitch. The pitch value is pitch value can be known from table given in question. Okay, for a particular DC value, core diameter value, this value is given in table. Okay, so 1 upon pitch is the value of small n. Then again next value is capital D. Capital D is 1.25 times nominal diameter to 1.5 times of nominal diameter. Then capital D1 is equal to nominal diameter plus 6 to 8 mm for plus 6 to 8 mm. Okay, so here 6 to 8 mm means you should take the mean value of 6 to 8, that is 7. Okay, so capital D1 will be equal to DO, that is nominal diameter plus 7 mm. Then D2 will be 1.5 nominal diameter to 1.7 nominal diameter. Okay, so here range is given, D2 will be equal to 1.5 to 1.7. So take a mean value, that is 1.6 nominal diameter. Likewise here also small l is equal to 1.1 to 1.25, means take a mean value, that is 1.15. Okay, 1.15 or 1.125, or take any value in between these. Okay, or take mean value. Best way, take mean value. Okay, then capital L value, that is length of nut, length of coupler, is equal to 6 into DO. So this value is fixed, 6 into nominal diameter. Then small t value is 0.75 to nominal diameter. So once you calculated all these value from DC, see the step number 3. In this small n, small l is known from this empirical relation, and sigma c is known. Okay, so if the induced stress value is greater than the design stress value, then we have to increase the parameters of a basic parameter. That basic parameter is small dc. Okay, we have to increase or take the next value of our dc value. Okay, take the next value, so all value will be changed, and induced stress will be less than design stress. If again the induced stress is more than the design stress, then take the next DC value. Okay, likewise we have to be sure about that the induced stress value will be less than the design stress value. Okay, after being sure, you have to take the next step. Then step 4, failure of coupler nut under tensile stress. So here capital D and small do is known from that empirical relation, and sigma t is calculated. Again check where the sigma t value, that is induced stress value, is less than design stress value or not. Okay, then step 5, failure of coupler under tensile stress. So here only 5 steps are given for turnbuckle, and it is a comparatively small design procedure than quarter joint or knuckle joint. Okay. The failure of coupler under tensile stress. The coupler effective area is this ring area, which is outer circle minus inner circle. So pi by 4 into d2 square minus do square. Okay, this is effective area. So PD upon effective area, which is equal is equal to tensile stress induced. Okay. So again, check induced stress is whether induced stress is less than design stress or not. If it is less, then it is okay. But if it is not less than design stress or it is more than design stress, then we have to increase this value. That is, we have to increase the basic value of core diameter of a nut. Okay. So once you increase the core diameter value, that is, once you take the next value from table, then you have to calculate all these value. Okay, we have to calculate all these value, and we have to design from these two. Okay, we have to design from this step. Once you increase the DC value, then all previous steps will be safe, already safe. There is no need to check again. So just start from this step. Okay, where you left. Okay, start from this step 5. Okay, and step 5 will be, once it is safe, then our design is complete. Okay, likewise this design procedure of turnbuckle will end. Okay, so it is a comparatively smaller than design procedure of quarter joint and knuckle joint. Thank you.